Happy learning. Piston pumps. Piston pumps are considered as the highly efficient pump and high pressure rating pump. The efficiency of piston pumps are from 90 to 98% of overall efficiency, and pressure rating is maximum of 825 bar. Now let us discuss the various type of piston pump and its working principle. There are two types of pumps, one axial piston pump and radial piston pump. Axial piston pumps are again divided into bent axis piston pump and swash plate piston pump. The bent axis piston pump. In bent axis piston pump, the motor side is at a horizontal position and the pump is connected at an inclined position with respect to the motor, and pump is connected at an inclined position and it is connected through the yoke universal link, the yoke mechanism, and the connecting rod is connected to the drive shaft flange, the motor side flange, drive shaft flange through the ball and socket joint. Now whenever the motor is started to rotate, along with that drive shaft also will be rotating, along with that the motor pump also will be rotating at an inclined position. So pump will be rotating about its own axis but at an inclined position. Now whenever the motor is started to rotate and along with the drive shaft, the connecting rod also will be rotating. Connecting rod is connected to the drive shaft through the ball and socket joint, and in one half of the revolution, the flange will be moving upward, moving the top of the flange, and the next half of the revolution, the same flange will be moving downward direction. When it is moving up, the connecting rod will be moving towards motor side. That is, the piston is moving from top bed center to bottom bed center, where the suction will be created, so that oil will be get into the cylinder. Now the same flange, in the next half of the revolution, the piston will be moving away from the drive shaft. That is, a compression will be taking place. That is, the piston is moving from bottom bed center to the top dead center, where the compression will be taking place. So this process will be repeated again and again. So whenever the flange is moving upward, the piston will be moving towards the drive shaft, that is the top dead center to the bottom dead center, suction will be taking place, and the next half of the revolution, the same piston will be moving from bottom dead center to the top dead center, where the compression will be taking place. Now both suction, the pumping action, that is suction and discharge, suction, compression, discharge, and this pumping action is based on the inclination, how the pump is inclined with respect to the motor side. However, this maximum inclination will be 30-degree angle. Beyond 30-degree angle, we cannot design the pump because of the design difficulties. Now see this bottom side, there is no inclination. So similarly, there is no suction, there is no compression will be taking place. Swash plate piston pump. In swash plate piston pump, the pump is at a horizontal axis and the motor side shaft flange, the drive shaft flange, that is a swash plate. The swash plate is connected at an inclined position. Now the theta, see the theta angle, the angle theta, it is limited to the maximum of 17.5 degree angle. Now the swash plate is connected to the motor side drive shaft, and the swash plate is in inclined position, and the swash plate, the connecting rod of the pump is connected and through the ball and socket joint, and whenever the motor is started to rotate, along with that swash plate also will be rotating at an inclined position, and along with that the motor also, the pump also will be started to rotate. Now when the piston along with the swash plate, the connecting rod also will be moving, and when the swash plate is moving up, in the half of the revolution, the swash plate will be moving up, When it is moving up, along with that, the connecting rod will be moving towards the motor side, drive shaft side. When it is moving towards the motor side, the piston will be moving towards the drive motor side. That is, it is moving from top dead center to the bottom dead center, where the vacuum will be created, suction will be created, and also the pumping action will be started. The oil is getting into the pump. In the next half of the revolution, the same piston will be moving away from the motor side. When it is moving away from the motor side, the piston will be moving from bottom dead center to the top dead center, where the compression will be taking place. And once the compression is completed, the high pressure oil will be getting into the fluid power system. This is how the Schwarz plate piston pump is working. And based on the angle, when the angle is maximum, the more pumping action will be taking place. And when there is no angle, when the zero Schwarz plate angle in the bottom side, see that the drawing, see the zero Schwarz plate angle, there is no angle, so there is no stroke, and there is no compression, and there is no pumping action will be taking place. This is the working of Schwarz plate piston pump. Radial piston pump. In radial piston pump, and the left side is the inlet chamber, outside is the outlet chamber. And the inlet chamber, the oil will be getting into the cylinder, and through the outlet, high pressure oil will be discharged into the system. And the outer layer is the fixed casing, and the inner will be there is the rotating cylinder block. This rotating cylinder block will be connected to the motor, and along with the motor, the cylinder block also will be rotating. In the rotating cylinder block, there are 6 number of cylinders, and these cylinders are touching. It is made to touch the fixed eccentric cam. Now the eccentric cam is, it is a fixed one, and the axis of the eccentric cam is eccentric with respect to the center of the pump, with respect to the rotating cylinder, axis of the rotating cylinder. So the axis of the rotating cylinder is different, and the axis of the eccentric cam is different. And this piston is connected with a spring return, and the piston will be moving towards the center, or it will be moving away from the center. So because of this, the eccentric cam, since all these cylinders are radially connected, and all these cylinders are made to touch the eccentric cam. And see this, the left side part, the piston is moving towards the center. See the direction of the piston. The piston is moving towards the center, where the suction will be created. Suction will be taking place. That is, the piston is moving from top dead center to the bottom dead center, because it is moving towards the center. Now through the inlet chamber, the oil is getting into the cylinder. The suction is taking place. Now in the right side portion, the same piston is moving away from the center. When it is moving away from the center, when it is moving away from the eccentric cam, the compression will be taking place. See the direction, the compression will be taking place, where the high pressure will be generated, and the high pressure oil will be moving through the chamber, discharge chamber, to the outlet, and it is connected to the fluid power system. So this is how the radial piston pump is working.